All right, we're working on problem 338 from the textbook, one of the extra problems. That was weird. One of the extra problems from the projectile packet. And it says this, we have building 1, a projectile is thrown with some velocity and goes a certain distance, we'll call it D, okay? And then we have another building of some unknown height, right? And we throw a rock or a stone or some kind of thing off of that with exactly the same initial horizontal velocity, correct? And then it goes a distance 2D. And we want to know what's the ratio, we'll call this H prime and H, right? We're asked what's the ratio of H prime to H? In other words, how much taller is the second building than the first building? We've been doing problems like this all year, so this sort of should be a familiar construct, okay? So now, the distance that an object goes when it's thrown from a height H. Let's take a look at that first. All right, just doing the chart thing, and we say here's the X stuff, here's the Y stuff, and we know that the V naughts, if it's thrown horizontally, then you guys recognize that Vx is going to be V naught, and V naught Y is going to be equal to 0. You okay with that? We can do that with sine and cosine, but if theta is 0, right, that means that V naught times cosine 0 is just V naught, because cosine of 0 is 1, and V naught times sine of 0 is 0, because sine of 0 is 0. Got that? All right, now, other easy stuff. Acceleration in the x direction. 0. Acceleration in the y direction. Negative g. We do know it, Katie. All right, so now, we know that delta x is going to be, we just called it d, right? Delta x we call d. And what do we call delta y? Nope, delta y. Yes, we call delta y h. Okay, delta y is h. And what is t? It's the bridge, but we don't know it, do we? All right, so we have t, which is the bridge between the two of them. Which direction are we going to be able to solve it for? I don't know. Let's take a look. How far is something going to go in terms of the height? Right? We know, what kind of problem is this?
Can we say y is 2D? Or
Well, we know that we have, just in general terms, delta y is equal to h. Okay? And then for the second time, we're going to do 2D, and we're going to see how h has to change. Okay? So what kind of problem is this? Taking a look at the figure up here. It is a half parabola. Okay, half parabola problem. So we're going to solve, what's a half parabola? That means it's a hits the ground problem, right? So we're going to solve in the y direction for time, plug that into the x direction. Okay? So we know that delta y is equal to negative 1/2 g t squared. Okay, because v naught y was equal to 0. You want me to write that out? But you know what? Let's do it just to be clear. Just to be clear, y direction in red anyway. Delta y is equal to v naught y t minus 1/2 gt squared. Fruit Ninja. All right, so we have that delta y is equal to negative 1/2 gt squared. That's what I said just a second ago. And then t is equal to the square root of 2 delta y negative over g. Right? All right, so now in the blue direction, or the horizontal direction, we know that delta x is going to be equal to v naught x, or v naught, right, times t plus 1/2 ax t squared. Again, we have a gift, right? So then we get the familiar delta x is equal to v naught times the square root of negative 2 delta y over g. Everybody okay with that? All right, so now for our situation, we'll just rewrite it in terms of the variables that we gave. We said delta x, what did we call delta x? We called it d, and we called delta y h, right? So Can you guys recognize that h is equal to the negative of delta y? Because if it falls this far, it's going to be a negative something. So h is just the negative of that because it's a measurement upward. Okay? And that way we'll just have positive numbers in there. So now d is equal to v naught times the square root of 2h over g. That's how far the first one is going to go. Or any one if we measure the height as h and measure the distance as d. Now we know that d prime over d is equal to what? We were told that the rock goes how far? D prime is the, go back to the figure, d prime 2d, this is d prime, okay? So it's going to be 2d. So d prime over d is just 2, right? Is equal to 2. We also know that d prime over d is equal to this expression using h over, this expression using h prime over this expression using h. Does that make sense? Here's what I'll say. What was d? D was v naught times the square root of 2h over g. That's what d is, right? I just put d over here. So what's d prime going to be? Exactly. V naught times 2h prime over g. Everybody okay with that? We know that the ratio of d prime to d is 2, so we know that the ratio of this expression for d prime over d is also equal to 2. Okay? So we're just going to work with this stuff right here. Got that? So I'll just rewrite it all cleanly. We know that v naught times the square root of 2h prime over g over v naught times the square root of 2h over g is equal to 2. All right, so now we'll just clean this up a little bit. V naughts cancel. So in other words, the answer to this question doesn't matter. Doesn't matter how fast we throw it in the horizontal direction to start with, does it? In fact, they didn't tell us, did they? They just said some velocity. Okay? So that's why we just gave it a name, v naught. We couldn't give it a value, but we did give it a name. All right, now we can square each side, and we'll get 2h prime over g over 2h over g is equal to 4. We squared each side. Okay? So now, let's, I guess we can do it the easy way. 2h prime over g times g over 2h. Got that? I just inverted this. Okay? Multiplying those two together, that's equal to 4. And then, easy to clean up, we got rid of the 2, we get rid of the g, and we end up with h prime over h is equal to 4. Another way of saying that, h prime is equal to 4h. That means we have to throw it off of a building that's 4 times the height in order for it to go twice as far, given that we throw both of them horizontally with the same speed. Okay? And that's similar to stuff that we've talked about before, because of the time. Remember, we've solved this for time before. Said that how long does it take for something to, if something drops from a height h, right? How high do we have to drop it from so that it takes twice as long to drop? We found that that was 4h before. So this is consistent with that. Because remember, it's traveling in the x direction the entire time it's falling. So if it for it to be twice the time if it takes 4 times the height, then that's answering the same problem, isn't it? Because we need twice the amount of time because it's going the same speed in the x direction the entire time. So to go twice as far, it has to be twice as long. Everybody okay with that? All right. Same.